Alright, 7.3 is where we evaluate log functions. So in 7.1.7.2, we already figured out that logs are the inverse of exponential functions. So what we're going to look at first is the different notation, how you write from exponential to logarithmic and then vice versa. And then we'll look at how to evaluate the logs without using the inspire. And then we will do inverse algebraic. Okay, so when you look at something like this equation, okay, that subscript is your what? You all remember from last class?
Base.
That's your base, yes. So it's read as log base 2 of x equals y. Okay, so you always notate your base, and then you're taking whatever is right here is what you're taking the log of. Okay. So when we are looking from exponential to logarithmic, because they are inverse, you have to understand the placement for when you rewrite. Okay, so if I'm looking at a base raised to any x exponent equal to any number y. Okay, so the base that is being raised to the exponent in exponential notation is the subscript that I have for my log. Okay. And then the exponent that the base is being raised to is actually what my log is equal to. And then what my exponential notation is equal to, that is what I'm taking the log of. Okay, so this log-based solution equals exponent. That is what we're going to keep repeating today's lesson and then the 2 lessons to come. Okay, log-based solution equals exponent helps you understand which term, which number that you're writing for when you rewrite it, where it goes. So if I'm looking at this, log-based solution equals exponent, that's how you kind of compare the two. Okay, so the restrictions with logs are that you cannot take the log of 0 or a negative number. And if you think about why you can't take the log of 0, that is in the y position right here. So if you trace it back, that means that I need a number raised to an exponent to equal 0. That's never going to happen because even if you raise a number to 0, it's equal to what? Anything to the 0 power is 1. So you're never going to raise something to a power and get 0. So you cannot take the log of a 0. Okay. Same thing with a negative, because if you took a negative here, a negative exponent just means it's in the wrong position. It does not make the value negative. Okay, so you cannot take the log of 0 or a negative number. You have to remember that. And that really comes into play when we do 7.5, when we're solving. Today we're just evaluating, not solving. Okay, so the first section that we do is just rewriting from exponential to logarithmic form. Okay, so if I have 3 to the 3rd power equals 27, that's my exponential form, and I need to rewrite it into logarithmic form. Okay, so I'm going to take my log. What's my base? 3. If it's log-based solution equals exponent, what comes next? 27, and that is equal to my exponent of 3. That's all we're doing. We're just rewriting. Okay, so if I have 2 to the 5th power equals 32, when I rewrite that, I have my log. What's my base? 2. Solution equals, good. Very simple. Okay, so if I have 4 to the negative 2 power equals 1/16, I want you to rewrite that one, and we're going to check. What do you have?
Log base 4 of 1 over 16 equals -2.
Very good. Okay. So our next section, we go from logarithmic form, and we need to rewrite it in exponential form. Okay, so if I have log base 5 of 125 equals 3, it's currently in the log base solution equals exponent. We need to put the base raised to the exponent equal to the solution. So how would I rewrite that?
5 to the power equals 100.
Very good. So then I have log base 8 of 4 equals 2/3. How do I rewrite that? What's my base? 8. What's my exponent? Equals 4. When you're rewriting it in exponential form, make sure that it makes sense. For instance, this one, if you rewrote it in a different form and say you put the 125 here, 5 to the 125th power would never equal 3. So when you're rewriting it, check it and make sure it actually makes sense. Okay, because this is a true equation. So my next one, I have log base 4 of 1, not 4. Log base 4 of 1 equals 0. So that means my base is 4. What's my exponent? 0 equals 1. And then log 12 of 12 equals 1. How do I rewrite that? 12 to the first power is 12. Okay. Okay, questions on rewriting? All right. When you are evaluating, you have to be careful. This is where we are going to have to use a one-to-one property, and you're going to have to manipulate bases to be equal. Okay, so if I tell you that you have log base 4 of 256, this is all I give you, and I say to evaluate it. Okay, if it says evaluate without using the calculator, that means evaluate without the inspire. Okay, that doesn't mean your actual scientific calculator that we use. Okay, the inspire, you can just type this and get a value, and that's why we don't use that for majority of our stuff. Okay, you have to know where everything is coming from. So the way that you're going to work this out algebraically is you set it equal to x for your first step so that you have an equation, because your final answer will be x equals a value. Okay, so you're always going to set it equal to x. Then you're going to rewrite it into exponential form, and then use the one-to-one property, which tells us that if your bases are equal, then your exponents have to be equal. Okay, so if I have log base 4 of 256 equals x, and I rewrite that in exponential form, what would I have? Yes, 4 to the x power equals 256. Good. So at this point, this is where I want my bases to become the same. Okay, regardless of where your exponent is, you will always work to get the larger number down to your smaller base. I see a lot of mistakes in this section of bringing the smaller number up to the, in this instance, 256. You want to take the larger number down to a smaller base. Okay, so if I'm looking at 256 and I'm looking at 4, I want 256 to have a base of 4. Okay, so if you don't know off the top of your head 4 to what power is equivalent to 256, you can just start plugging numbers in your calculator. You know 4 squared is 16. What's 4 cubed? 64. So what's 4 to the 4th?
4.
256. So I'm going to replace 256 with 4 to the 4th, and then I just bring down my 4 to the x power. So again, you're only changing the larger number, and you bring it down to the smaller base. Now I have equal bases. That's my one-to-one property. So if my bases are equal, that means my exponents are equal, and I can say x is equal to 4. Okay? So my next example that I have is log base 1/5 of 125. So my first step is to set it equal to x, and then I rewrite it. How do I rewrite this? 1/5 to the x power equals 125. Good. Okay, now when we have fractions, we have to make the larger number, which is 125, the smaller base. I do not want it to be a base of 1/5. I want it to be a base of 5. So when you have a fraction, whatever your denominator is, that's the base you want them to become. Okay? Now, 1/5 and 5 are not the same. So that means I'm going to also have to manipulate this 1/5 to become a 5. If I want to make this become a 5, what is the only way I can bring that 5 from the denominator up to the numerator? If I multiply by 5, that gets canceled. So we can't do that. We have one rule, one property, that's from chapter 6. I heard it. The negative exponent. You don't make the 5 negative, you use a negative exponent. Remember that whenever we would have something, an example like 5 over x to the negative 3. Say you have that. What would you do with that x? You would move it up, and that would become 5x to the 3rd. You remember that? Okay, you're using that negative property, but in the opposite way. Okay, we knew that a negative exponent needed to be moved, and when you moved it, it became positive. So we're going in the reverse way. I have a 5 in my denominator. I want it to become just a 5. So I'm going to create a negative exponent because 5 to the negative 1 is 1/5. Okay, and then I have x as my outer exponent. And then that 125, I want to have a base of 5. 5 to what power? 3. Okay, so again, if you have a fraction, you want to move it up with a negative exponent. That does not make the base negative, it makes the exponent negative. Okay, now what property do I have an exponent raised to another exponent? What do I do with this? If I had x squared raised to the 3rd power, what did that become? X to the 6th. That's my power property. If I have a power to a power, I multiply. So here I have a power to a power, negative 1 in x becomes negative x. So I moved my 5 from the denominator, I tacked on the x and multiplied, and then I manipulated the 125 to have an equal base. So now negative x is equal to 3, divide by negative 1, and x equals negative 3. Okay? As you do examples, you should be able to go straight from that 1/5 x to 5 to the negative x. I do not need to see you make it 5 to the negative 1 raised to the x. If you need to put that, then do that, but I don't need to see this. You should be able to go straight to that. Okay? Do we have questions on that example? All right. So now if I have log base 2 of 0.25 raised to the 4th power. What's my first step? Set it equal to x. And then I rewrite. How do I rewrite that? What's my base? 2 to the x equals. Now, what do we know about 0.25? What does that equal to? So this is really 1/4 raised to the 4th. So when I give you a decimal, you want to put that into fraction form so you can see what base you want. Okay? So if you're looking at 2 and 1/4, which side am I going to manipulate, the 2 or the 1/4? The 1/4. Okay? If you have a fraction, remember you're looking at your denominator. Which one's larger, the 2 or the 4? The 4. So I need to take this 4 and I need to manipulate it to become a 2. But I also need to do what with it? If it's a fraction, I need to move it up. Okay? I don't want to work with fractions. I'm going to move it up. So I'm going to have 2 to the x power equals, what is 1/4 going to be with its like base moved upward? How am I going to write that? Okay, so this is 4 to the negative 1 raised to the 4th. But 4 is really 2 to what power? 2 squared. So this is 2 to the negative 2 raised to the 4th power. Right? Because 1/4 is 1 over 2 squared, yes? Because 4 is 2 squared. You take that and you move it up. That's 2 to the negative 2. Then you have your outside 4 from my original problem. Now I need to use my power property. So 2 to the x power is equal to 2 to what power? Negative 8. Now I can have equal bases. So I need to set my exponents equal to each other. X equals negative 8. When you have a fraction, you want to move it up. Okay? You'll always have that negative exponent when you move it up. All right, so my next one, I have log of 1/8, base 1/8 of 1. I'm going to set that equal to x, and I rewrite it. So I have 1/8 to the x power equals 1. Okay? What's your thought there? Mm-hmm. So what we've been doing is you recognize it's a fraction. So your instinct should be to move that fraction up. Okay? So 8 to the negative x equals 1. Then if you're going with the same process, I keep saying you're going to take your larger number and make it a smaller base. So that means I would need to take my 8 and somehow become a 1. Is there any possibility of doing that? I can't manipulate an 8 to become a 1 because 1 to any power is still 1. Okay? So I need to think about one rule that we have that makes any base equal to 1. 0. Anything to the 0 power is 1. So that means x is equal to 0. There is no work. So technically, if you don't do this, you should be able to look any base raised to x equals 1, you should be able to go straight to x equals 0. But if you do the 8 to the negative x because you know I need to make any fraction come up, that's fine too. Either way, x has to be equal to 0. You have to know your 0 property. So your exponent rules that might have been a struggle with chapter 6 are going to carry on to this because these are inverse of exponents. Okay. So our last example, we have log of 1 over 25, log base 1/25 of 1/5. So I want you to actually do this one on your own. I want you to try it and then check. What's your first step? Set is equal to x. And then you rewrite it. So you have 1/25 raised to the x power equals 1/5. Okay, the first thing you should recognize is that you have fractions. And what do we do when we have fractions? You move it up. So this 25 gets moved up and this 5 gets moved up. So if I'm looking at it, then that's just 25 to the negative x equals 5 to the negative 1. Can I say negative x equals negative 1? No, because I don't have like bases. So what do I need to do? The larger number, which is 25, needs to get manipulated to have a base of 5. So 25 is the same as 5 to what power? 5 squared. And that's raised to the negative x equal to 5 to the negative 1 power. Now again, I'm writing this because these are the notes and I want you to see where it's coming from, but you should be able to go straight from 25 to 5 to the negative 2x power. And that is equal to 5 to the negative 1. Now I have like bases. Negative 2x equals negative 1. Divide by negative 2, and x equals 1/2. Okay, so a lot of y'all were doing that as I was doing it. So what did y'all get stuck with? After you flip them? Okay. So breaking it down like this, do you see how this comes down to 5 to the negative 2x? If you see that 25 is 5 squared. Okay, do y'all need another example or are y'all good to move on?
I need another example.
Okay,
No, we don't.
do you?
Yes.
Okay. Look at your worksheet. We're going to do 2 of them. All right, so let's start with 13. Okay, I want you to look at 13. Log base 1/2 of 8 is what I have. What's my first step? Set it equal to x, and I rewrite it. So I'm going to have 1/2 x equals 8. Okay, I have a fraction. What do I automatically do with the fraction? I move it up with a negative. So 1/2 to the x power is the same as 2 to what power? Negative x. Do we all get that? Okay. Now this 8, I need to manipulate, right? I need to make the larger number have a smaller base. What do I want that 8 to become? 2 to the third. So then negative x equals 3. So x equals negative 3. Okay. Does that make a little bit more sense? Okay. Let me go on another one.
So you just manipulate the bigger number, no matter what.
No matter what. Yes. So you always change the fraction to have a negative exponent to move it up, and you always manipulate the larger number. Okay?
Yes.
So knowing that, let's do let's do 16. Well, you do 16, then we're going to see if you got it. Okay, what's my first step? Equals x and rewrite it. So how do you rewrite it? Good. Okay. Which one do I change? What do I do with 1/4?
4 to the -1.
Okay. What do I do with 16 to the x? Do I leave it?
No, you change.
I change it to have a base of 4. So 4 to what power? 2x. Good. So then 2x equals -1. Divide by 2, x equals -1/2. Okay? We good? Do we have
Yes, we do.
questions? Okay. Alright. So now we're going to look at special logs. You've got common logs and natural logs. And then you have logs of any base. Okay, so common logs and natural logs are considered special. Your common log is when there's a base of 10. And that is when you're going to have log of x with no base written. Okay, so just like if I give you x, the coefficient of 1 is understood. If I give you log with no base written, it's understood to have a base of 10. It will not be written. Okay, the natural logs have a base of e. Okay, and that's written as natural log. The e for the base will not be written. So if you think back to when we did the word problems for exponential and you had compounded continuously, you had a equals p times e to the RT power. That e comes from the base of natural log. Okay, so if you have the natural log of 5, it's going to look like that without the base written. Just like if I took the log of 5, that is not going to have your 10 written as your base. Okay, so you have to know the moment you see something without a base, natural log is e, log is 10. Okay, and then you need to know that natural log of e is equal to 1, just as log of 10 is also equal to 1. Because if you think about rewriting your base raised to the exponent, log base solution equals exponent, your base for natural log is e, so e to the first power is e. Just like log has an understood base of 10, 10 to the first power is 10. So you need to know when you see natural log of e, that's 1, and log of 10 is 1 also. Okay? So what we're going to do, these 3 examples are really simple. It just says using a calculator, find the value of the following log, round to 4 decimal places. Okay? So if I give you log of 87.5, you are just going to type it in your calculator and get the decimal. Okay? So these calculators, the scientific ones, only do common log and natural log. Okay, so if you don't remember how to get there, the button next to math, that PRB button, has log in gray. So you're going to do second, then that button. And you already start with log, so just press enter. So I'm going to have log of 87.5, and it gives me that decimal. So I'm going to round it to 4 decimal places. 1 point what? 9420. Good. There is no partial credit. You either typed it in and got the right answer, and you rounded correctly, or you didn't. Okay, so it's right or wrong for these. Okay, so my next one, I've got log of 0.0038. So you do second log, 0.0038. What am I going to put as my answer rounded to 4 decimal places? Good. Okay, my third one is if I have natural log of 3.925. So to get to natural log, you still do the same buttons, second log, but now you go to the right. That gives you your natural log 3.925. So you should have 1.3674. Okay, we're good with that? Alright. Now, when we do our inverse function, this is the last section of the notes. We did inverse for polynomial functions in 6.6. Okay? We solved for it algebraically, and then we also graphed it. When we did 7172, our exponential and log, that is graphing your inverse, okay? Because they are inverses of each other. So when we do it algebraically, we're going to mimic those same steps that we did with 6.6, but we're going to be flipping back and forth from exponential and logarithmic notations, okay? So if I have my first example of f of x equals natural log of x plus 3, if you think back to 6.6, when we did inverse algebraically, what was our very first step? Y'all just took a test over this. You switch your x and y. So x equals natural log of y plus 3. Okay, once you switch your x and y, you're going to rewrite that. If I start with logarithmic form, I'm going to rewrite an exponential. If I start with exponential, I'll rewrite in log. Okay, so if I'm looking at natural log, if I'm doing log base solution equals exponent, if I know that, that's what I'm going to use to rewrite this. I have natural log, so what's my base? That's a special log.
E?
E. Okay. If you even looked at your calculator, when you do your log option, log goes with 10, natural log goes with E in your calculator. So those go hand in hand because they're inverse. So I have an understood base of E. So when I rewrite that, I have E to what power?
The power
X, because it's log base solution equals my exponent. So e to the x equals my solution y plus 3. Okay, now I want to solve for y, so what do I need to do? Subtract 3. So y equals e to the x power minus 3. Now when you write that, please be careful with your handwriting and your notation. You need to make sure that whatever is an exponent is clearly an exponent and everything else is not. Okay, if you write x minus 3 and it looks like the minus 3 goes with the x, that's going to be wrong. If you have ex instead of e to the x power, that's going to be wrong. So be careful with your notation, okay? Now, when we do inverse, what should our final answer look like?
-1, y to the -1.
Y to the -1 power. Okay? So our next example, I have f of x equals log of x minus 5. So my first step, switch your x and y's. X equals log of y minus 5. Then I need to rewrite it in exponential form. What's my base? 10. Understood to be 10. So I rewrite it 10 to the what power? Equals, good. So what's the inverse of y equal to? 10 to the x power plus 5. Very simple. Okay? Now if I have f of x equals 3 to the x power. I swap x equals 3 to the y power. I'm starting an exponential. So that means I need to end with what?
Logarithmic.
Logarithmic, okay? So if I write my log base solution equals exponent, how am I writing this? Log of what? Log base of equals. So the inverse of y is equal to log base 3 of x. So if you know that exponential and log are inverse, and you recognize this is the parent function exponential, you should be able to go straight to logarithmic parent function, okay? When I was learning this, if you did any work before you got to your answer, you got the whole problem wrong, because you were expected to know it, okay? If you need to rewrite your x and your y, because that's our process for you to see that you rewrite it log base solution equals exponent, that's fine. I'm okay with that. Okay, because that is the process of inverse. But in reality, you should know that anything b to the x, its automatic inverse is log base b of x. Okay, but again, do your process if you need. Okay. Our last one, we have f of x equals log base 3 of x plus 4 plus 5 at the end. Okay, so our first step, switch your x and y. X equals log 3 y plus 4 plus 5. And if you're working this, what would you do?
Three is
Okay.
your base.
Huh?
3.
3 is your base. Okay.
So 3 to the power of x, right?
So before I rewrite it, I've got to consider this plus 5 tacked on. Okay, so this log term is all of this. This is one term. Okay, I need to move this 5 away from the log before I can rewrite it. Okay, so that means I've got log base 3 of y plus 4 equals x minus 5. Then you can rewrite it. Okay, you have to isolate your log before you can rewrite it. So then my base is 3, like y'all were saying, but now what's my exponent? X minus 5. That is my full exponent. And that is equal to y plus 4. So then, inverse of y is equal to 3 to the x minus 5 power minus 4. So if you have a constant tacked on, that just means you need to move it to the other side before you rewrite it. Okay, are we good with that? Okay, you do have a quiz next class.